Okay, so when we look at ionic bonding, it's a bond between a metal on the right hand side of the periodic table and a non-metal. So you can identify a compound that will be an ionic compound because it's always formed of a metal and a non-metal. Now, as you saw in this video, we're going to look at two different things. We're going to look at bonding between simple ions and something we're going to call complex ions. Simple ions are just elements that have become charged. So you can see sodium here is found on the periodic table, but it's undergone a change. It's lost an electron to become a sodium cation, or a positive sodium ion. And you can see there's a pattern here. Anything from group 1 in the periodic table will gain 1 positive charge. Anything from group 2 will gain 2 positive. Aluminium you'll see sometimes at GCSE, that's over here, that's in group 3, and I'll get 3 positive charges. So these things that you find on the periodic table are what we're going to call simple ions. These larger things here that look like molecules with charges, they're what we're going to call complex ions. So you can see here, these are simple atoms that have got a charge. This is 2 different elements stuck together. It's an oxygen and a hydrogen, and they're bonded together, but they've also got a charge. So the complex ions that we'll look at later are hydroxide, sulfate, carbonate and nitrate. The H, by the way, tends to mean has oxygen added to it. So carbonate has oxygen, sulfate has oxygen, and so on. So let's have a look. We've got the selection of metals from the left hand side of the periodic table that we know are going to form positive ions, and we've also got some non-metals here. So the first one we're going to try and show is magnesium oxide. Now it's always a good idea when you do this on paper to show the actual atoms first. So you can show that we're going to start with a magnesium and we're going to start with an oxygen. That'll save you getting confused later on when you're trying to show them bonded together, because if you draw them bonded together first off, you could end up getting the number of electrons confused. So we've got magnesium oxide. So we've got a formula for that, would be magnesium and oxygen. We don't know yet what kind of a ratio they're in, but we can work it out. If magnesium is in group 2, we know it's going to give away 2 electrons. Oxygen is in group 6, so it's going to need 2 electrons. So between them, they're going to balance out. They're going to be able to provide on a 1-to-1 ratio the exchange of electrons they need. Magnesium is going to give away 2, oxygen is going to gain 2. So we've started off with a magnesium and an oxygen. Let's try and show now what's going to happen later. So you can think of this as being before and after, and we're going to look at the after now. So we've got a magnesium and an oxygen. At the moment, neither of them are stable. The oxygen has got 2 electrons in its outer shell. It needs to have a full outer shell. So what the magnesium does is it loses 2 electrons, and they go to the oxygen. Still got 1 left. It needs to lose that one as well. So now we can see the magnesium has lost 2 electrons, so it will have 2 more protons than it has electrons. So we can put a little kind of bracket around that magnesium to show that it has 2 positive charges. Okay, with the oxygen, it's gained 2 electrons, so it is going to have 2 more electrons than it has protons. So again, we can put a bracket around that to show that it has 2 negative charges. So we only need 1 magnesium ion and 1 oxygen ion to balance the charge overall. Just like in covalent bonding, in ionic bonding, both the atoms are trying to become stable. They're trying to achieve a full outer shell of electrons. Let's have a look at a different example. We've got here lithium fluoride. So obviously we need one lithium atom, we need a fluorine atom. Now I know if lithium is in group 1, it's going to make one positive charge. Fluorine's in group 7, so it's going to make one negative charge. It needs to gain one electron. So that's what they look like before they start. Let's show what they're going to look like after they've bonded. So this is before and after. So lithium currently has one electron in its outer shell. It needs a full outer shell, so it's going to give away that one electron. Luckily, fluorine needs one more to get 8 electrons in its outer shell. So we can see there that lithium will now have one more proton than it has electrons. So lithium will have one positive charge. Fluorine has now got one more electron than it has protons, so it will have one negative charge. Whoops. Here we go, let's do that again. It's got one negative. Whoops, there we go, and one positive. So we can see if we're trying to work out the formula for lithium fluoride, it only requires one lithium atom and one fluorine atom. So it's LIF, one atom, one atom. Okay, notice that fluorine on the periodic table is called just fluorine. When it becomes an ion, it's called fluoride. So fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide. Okay, so magnesium oxide. We need a magnesium atom, an oxygen atom. Magnesium's in group 2, it wants to give away 2. Oxygen's in group 6, it needs to gain 2. So let's do the same again, before and after. Okay, so magnesium gives away 1 electron, gives away 2 electrons. Magnesium, the charge on that will now be 2 positive because it's got 2 more protons than it has electrons. Oxygen will have 2 more electrons than it has protons. There we go. So our formula will be magnesium oxide. So everything we've looked at so far has been on a 1-to-1 ratio. But now we're going to look at something a little bit more difficult. We're going to mix up magnesium, that's in group 2, with chlorine, that's in group 7. So here's our magnesium. We can see that that's going to give away 2 electrons. And our chlorine, each atom needs 1 electron. So we'll try and do this a little bit differently. There's magnesium and chlorine. We'll show before and after. So we know, let's get rid of that one. Magnesium, because it is going to give away 2 electrons, it can choose to give 1 to the 1 chlorine atom. So this chlorine atom is now stable, it has 8 electrons in its outer shell. It can give away its other outer electron to this chlorine atom. So we've got a 2+ charge here on the magnesium. Whoops, it's a bit messy. So 2+ there. Chlorine here has gained 1 electron, so it's 1-. Oops. Chlorine is 1-. And of course this chlorine is also 1-. So our formula this time isn't going to be as simple. There's 1 magnesium, there's 2 chlorines. So when we write it this time, we put down the elements that are involved, the atoms that are involved. We've got 1 magnesium, so we don't need to bother putting the little 1 there, but we have got 2 chlorines. So the formula for magnesium chloride would be MgCl2. Let's have look at another example that's not so straightforward. Lithium oxide, we need a lithium and an oxygen. Right, we can start to think that something's not quite right here, because we know oxygen needs 2 electrons, lithium's only going to give away 1. And silly me, I've drawn 2 there. So lithium's going to give away 1. Obviously we need 2 lithium atoms to provide the necessary amount of electrons. So I can show that lithium is going to lose 1 electron. This lithium is going to lose another electron. So now we have a charge on this lithium atom of +1, or 1 plus, because it's got 1 more proton than it has electron. The oxygen has got 2 more electrons than it has protons. And lithium, this one, also has 1 plus. And if you think back to the table we looked at the start of the video, lithium was in the group of 1. We know it's going to give away 1 electron, so it's always going to have 1 positive charge. So let's see what our formula is going to look like. We've got lithium, we've got oxygen. How many lithium atoms have we got? 2. How many oxygens have we got? 1. Lithium oxide. Now, we can speed this up a little bit now. We've looked at the patterns, we looked at the relationships. So lithium chloride, we can probably make a good guess, is lithium, chlorine. It's going to make a chloride ion. That one gives away 1 electron, that gains 1 electron, so it's a 1-to-1 ratio. Magnesium chloride. Magnesium's in group 2, so it's going to give away 2 electrons. But chlorine only needs 1 electron because it's in group 7. So this time we need 2 chlorines. 1 chlorine will accept 1 of the 2 electrons from magnesium. The other chlorine will also accept 1 of the 2 electrons from magnesium. Lithium oxide, we've done that already. So lithium, group 1, oxygen, group 6. This needs 2 electrons. Lithium, each lithium atom will give 1 electron. Magnesium oxide, we've done this. Aluminium chloride is a little bit tricky because you've got aluminium's in group 3. So this time we've got aluminium, we've got chlorine, but aluminium wants to give away 3 electrons. Each chlorine atom only wants 1 electron because it's in group 7. So this time we need 3 chlorine atoms or ions to accept each of those electrons. And aluminium oxide is probably the trickiest. We've got aluminium, we've got oxygen. Aluminium gives away 3, oxygen needs 2, and we've got a bit of a problem there with those numbers. If aluminium is going to give away 3 and oxygen is going to give away 2. So what we can say is try and find a common number between 2 and 3. So 2 and 3 both go into 6. So if we have 2 aluminiums, we've got 2 times 3, that's 6 electrons being given away in total. And to get 6 electrons gained from oxygen, we've got 3 oxygen atoms, each wanting to accept 2, so that's 3 times 2 is 6. 3 times 2 is 6, 2 times 3 is 6. Okay, so these are all simple ions, and they're all found on the periodic table. Now these look much more difficult. These are complex ions, and you can see we've got nitrate there. It's got quite a big formula in itself, and ammonium there has got a big formula. So let's have a look. If we do ammonium down the bottom here, so that's NH4, that's got 1 positive charge. And if we've got nitrate, NO3, well, we can see that's got 1 positive, nitrate has got 1 negative, so the formula is just as I've written there. It's a 1-to-1 ratio. This has given away 1 electron, that has gained 1 electron. Let's try another. Ammonium hydroxide, very similar. That is giving away one electron. Hydroxide only needs to accept one electron. So again, you've got a 1-to-1 ratio, ammonium hydroxide. Potassium sulfate. So sulfate, you can see there, has 2 negative charges. Oh dear, and potassium's in group 1. So there's our potassium and sulfate. This needs 2. That can only give away 1 electron, so we'll need 2 potassiums to give away enough electrons for this to be neutral overall. Calcium sulfate, our last example. Calcium is in group 2, so it can give away 2 electrons. Sulfate has got 2 negative charges on it. This can give away 2 electrons. This can gain 2 electrons. So overall, calcium sulfate is neutral, and we don't need to put any other little numbers in around here. Remember, this is the only time that we change little numbers in our formula. When we're balancing equations, we never put little numbers down here. We only put big numbers in front. So for example, if I just did that now, if I put a large 2 here in front of the compound, that would mean overall I've just got twice as many atoms. So I've got 2 calciums and 2 sulfates. Okay, that's ionic bonding.